Okay. All right. I think there's just a couple more people to come in. All righty, let's kick off. Can you hear me through speakers? Yeah. All right. So, welcome to Cloud Native London. It is really good to see everybody again, especially since last month I had to cancel this very unexpectedly at very short notice. So very sorry about that, but I'm glad that everybody found their way back here today. Excuse me. We are a strong, open, diverse developer community dedicated to the cloud native platform and technologies based in London. My name is Cheryl. You can find me online at ocheryl.com. I'm a senior director at ARM, but most people know me from my time at CNCF. Previously, I was building stuff at Apple and at Google. Tonight, we have 3 speakers for you. Our first talk from Zahir is called AI Model Hosting on Kubernetes. Then 7:15, we'll do moving CI/CD closer to the developer with Kubernetes, fast feedback along the whole code path from Lewis. We'll take a break at 7:45, come back at 8 o'clock for software development is an art, why it's so difficult to estimate tasks from Michael. And then we'll wrap up at 8:30 and go to the pub afterwards, which is the Conductor. So out of this building, it's just in front of you on the left. Okay, Code Your Future has a little announcement to make. Do you want to come up and say a few words?
Hi, everyone. My name is Carla. I am coming in behalf of Code Your Future. I don't know if you know about Code Your Future, but can I change the slides? Yes. Code Your Future is an organization, a charity. Is with no profit. We are helping to people to how to learn coding, cloud, DevOps. We are giving this opportunity for all backgrounds people, diverse people. So we can do this alone. So we are needing helping from companies like yours to help with us hosting our classes on Saturdays. We are providing every Saturday classes. Our program is running for nearly 1 year, where we are learning a lot of stuff. So also we are needing volunteers that they are having a lot of expertise, and we can guide our trainees to help more improvements in their work or portfolio. So for now, we kicking off our program this September, and it's running through all year until October next year. So if you might know someone that can volunteer who wants help us to donating any laptops that are not in use for now, you can support us because our trainers need these helps. Also, we are looking for financial support. If you know about this as well, you can contact us by via LinkedIn if you want. Thank you so much.
Yeah, wonderful opportunity to volunteer your time or some help or some old laptops, whatever you can. Okay, our sponsor for this evening, Cloudified. Whereabouts is Alex? Okay, do you want to come and say a couple of words?
Hey, thank you very much. We help businesses use AWS as efficiently as possible and get the best bang for their buck out of that behemoth. So if that's something that interests you or affects you and you need help with that, let me know or find out more info on the website. Thank you very much.
Thank you. Okay, and now time for some live polling to find out about yourself. So please grab your phones and scan this QR code or go to this link. We're going to do a bit of live polling. I'm going to ask 2 questions about you and then 3 questions from our speakers about how you use cloud native. You don't need to download anything. It will just open up this page on your phone. Okay, is this your first time at Cloud Native? I can see people already started to answer no's. Oh, a couple of yeses. The people who do no's are the people who've done this before, so they're a bit faster off the draw. Yeah. Oh, really? Can you consider? Oh, try refreshing, because some people clearly are figuring it's working for some people. That's curious. Any luck? Yeah, better? Okay, cool. Probably just transient thing, hopefully. All right, looks like the yeses are starting to catch up. We are live streaming this to YouTube and to Twitch as well, so there might be people at home who are also answering this question. Amazing. Looks like we have about 60-40 new people and people coming back. Second question, what's your job title? Let's pick whatever's closest to what you do. Your options are architect, application developer, backend developer, engineering manager, DevOps/platform engineer, security engineer, or anything else. And the DevOps and platform engineers are racing ahead today. Looks like about half the crowd. Couple of others coming up. Quite a lot of others as well. Be interesting to hear what the other, if you voted for other, what you do. Oh, okay. Still couple of answers creeping in. Okay, nice. All right, we're going to go to our next question, our first one. Does your latest AI feature cost more than it brings in revenue? Yes, no, or oh, I have no idea. Somebody else deals with that. This question is coming in from Zahir. Lots of people are quite confidently saying, I have no idea. And then kind of, yeah, the yeses are slightly edging ahead. I guess people can think about this. So Zahir, is this what you were expecting?
Yeah, completely expecting this. With the current wave, everyone's doing random AI crap that brings in no real revenue. So
yeah, you're not hearing much. I think it is hearing. It's just quiet. Okay, we might have to talk a bit louder. Yeah. There's a bit of a fan noise. Okay, we'll just talk a bit louder into the microphone. That might help. Okay, yeah, looks like most people say they're not sure, and a handful of people are saying yes, and some people saying no. All right, our next question. Have you ever run CI/CD totally within Kubernetes? Oh, the no's are very quick off the draw. So yes, no, or not in production. This question comes from Lewis. And the no's are kind of out there, 55, 56%. 10% saying not in production. So I'm curious, Lewis, like what elements of CI/CD would you count in when you say totally within Kubernetes?
I suppose the sticky bit for a lot of people is going to be the CI aspect. Lots of people are on GitHub Actions, GitLab, whatever, or possibly Jenkins. What I'm referring to with this kind of question is using a flow such as Argo events and workflows, or Tecton or something like that.
And yeah, looks like most people saying no, but oh, thank you, Stephen. Yeah, a good chunk of people also saying yes. So that's good to know. That's pretty positive. And we will go to our third question of the evening. Which aspect of software development do you find most challenging to estimate accurately? Task complexity and uncertainty, integration with existing systems, changing requirements and scope creep, human factors and team productivity, or other? Might give people a little bit of a time to think about this one. This one's, I think, that's what. Which one is a no-brainer? Changing requirements? I don't know. I think some people might be answering and then thinking about it and changing their mind. Is Michael here? Ah, yes, there. Yeah. So task complexity and uncertainty and changing requirements and scope creep really sort of neck and neck there. Is this what you thought the answers would look like?
God, otherwise my presentation would be really stupid.
Okay, if you didn't hear that, he said, yes, thank God, otherwise my presentation would be really stupid. So I'm glad to know that the audience agrees with you. And yeah, looking forward to seeing what your presentation elaborates on here. Wonderful. All right, thank you very much, everybody, for joining in with the live polling. Keep it open on your phones because we'll use it for questions during the talks as well. Okay, I need to take a selfie for social media. So everybody hang on. Okay, if you feel like speaking or sponsoring some of our events as well, please go to cloudnativelun.com. Our speaking slots are booked up until, I think, 2025. There might be one or two left at the end of this year. So just sort of plan ahead if you're thinking about speaking. And that's it. I'm going to now stop my share and hand it over to our first speaker of the evening, Zahir. Big round of applause, please.
Hiya, good evening. Hopefully you've consumed pizza, drunk a few drinks. So I'm going to be talking about AI model hosting and whether you should use Kubernetes or not. And so first, a little bit about myself. I've been at Cisco for the last 14 years, out of which the last five years I've been involved with cloud native related stuff. Been working on Kubernetes platforms, and recently I moved to an AI team. So hence the talk to be on AI. Obviously, none of these pictures are anything to do with Cisco or my talk, but as you probably tell from the pictures, I support Liverpool. Any Liverpool supporters in the room? A couple. Okay, sad. Sorry? In Liverpool. Okay. I did not know that. So other things, I like golf. May not be very good at golf, but I do like golf. I like cycling. I'm worse at cycling. You can see a picture of bikes outside the Eiffel Tower, at some random train station. It's around some mountains. And I do a bit of running. I did not put any running pictures in because I do not like running. So that's a little bit about myself. So my talk, I'm just going to go through a few things, who Cisco is, and also specifically what WebEx is, and what AI we do. I'm going to talk about inference serving, and just some takeaways. So Cisco, show of hands, who has not heard of Cisco? I don't believe you. So I'm just gonna talk about what we do with CNCF, Platinum CNCF member and Gold CNCF member, because we bought Splunk recently. We bought Isovalent last year or this year, earlier this year. And Cilium is a CNCF project. It graduated, can't remember when, in 2023, I think. And it's usually people's default CNI choice now. And Cisco has a lot of engineers that contribute to a lot of CNCF projects, including Kubernetes, OpenTelemetry, and things like that. I've contributed to Kubernetes docs, not much else, sadly. That will change. WebEx. Now, who doesn't know what WebEx is? A few of you. Okay, so the stuff we're using here is Zoom. It's similar to Zoom for meetings. We also do chat like Microsoft Teams, and we also have a contact center and a whole load of other things. But with a lot of things these days being hot with AI, we have done a whole load of AI features. I actually had to go to this website, www.webex.ai, to get this list, because a lot of these I'd forgotten that we do. Some of the things that are to do with audio and video, which is probably where our main core competence is. Things you've probably seen, like background noise removal and virtual backgrounds, but also pretty neat stuff like the AI audio codec we announced recently. It's a lot lower bandwidth requirement for the same quality, and then a whole load of things with using what most people think is AI, the LLM stuff. So summarizing a whole load of stuff. I know I use ChatGPT to send any PDF that people send me because I don't want to read the whole thing. Similar stuff for calls and meetings. We also have an AI assistant for WebEx, which I guess similar to Alexa and Google Home and things like that. But with context regarding what you're doing, whether you're in a call, whether you're in meetings, etc. And I saw a lot of people respond to the poll that they're platform developers or DevOps. We do some usage prediction that helps our team go and decide about scaling. And we do a lot more, and there's more coming. And now I'm going to go on to hosting options for AI. And I've bucketed them into 3 different buckets. This one's probably the one a lot of people are familiar with. OpenAI, who create ChatGPT, provide an API. Anthropic do for Claude. AWS provide a whole load of open source models that you can go and use through Bedrock, and you can just get a credit card, put it in, and you pay for every use. Normal, easy consumption. No infrastructure to manage, which is great for us guys that work on platforms. Means we're less likely to get paged, except see the graph down there. This is a very recent graph from today, 2 o'clock. Outages reported on OpenAI. These are all things that completely out of your control. It's OpenAI has had this level of outage. Also, these guys will rate limit your stuff. So if you're depending on any of these things and you get sudden burst of traffic on your service, you might start get rate limited by them. And the big thing, I guess, for especially in Europe, because I don't think people in North America care as much, is privacy. You're sending all your queries out there. Maybe they are learning from it and improving the model, etc. But it's a decent option to start with. And this one is managed hosting. So this is where you get people like AWS to go and host a bunch of infrastructure for you. You can. It's reasonably flexible. You can run any model you want, whether it's one you've built, one you've downloaded from the internet, and you can make it auto scale. And if anyone is anyone an ML engineer here? Oh, okay. I better be careful. I'm not an ML engineer, but supposedly it provides a great tool set for ML engineers. It provides things like Jupyter notebooks and training pipelines and things I don't understand anything about. And one feature, I guess, feature for AWS, not necessarily for us, is they make a big markup compared to the actual cost if you were to do that infrastructure yourself on EC2. And we're at a CNCF talk. So we talk about self-hosting on Kubernetes. Yeah, you can run any model, just like you can run any application you want on Kubernetes, as long as it's just not true anymore. You can run things that are not containerized on Kubernetes, but you can run any model you want. You have all the flexibility of what the community have provided with auto scaling things. You've got for infrastructure auto scaling, you've got things like cluster autoscaler and Carpenter and probably a few others. You also have things like KEDA and horizontal pod autoscalers and vertical pod autoscalers, all sorts of things that you can use them just on your models, just as you would on other apps. We're going to hear a talk about CD very soon. That's a nice advantage to running these things on Kubernetes. It's the exact same deployment pipeline as you would for your other apps that you run on Kubernetes. Now, you have to manage the infrastructure, which could be a pain, but a lot of, 40%? Do we have 40% who are platform engineers here? So get paid to do that. So maybe it's an advantage. But you really need to optimize to reduce costs. So question earlier that I asked the audience was about whether the AI features cost more than the revenue you get. And the answers was basically what I was expecting. When I talked to people at other companies at KubeCon Paris, I talked to people at AWS reInvent last year. It was the same thing coming back, that our stuff costs more. We do not gain that much in revenue by doing it, but we have to do it because, I don't know, some venture capitalists won't invest in our company. We won't get free marketing for having the word AI somewhere. etc. So that's the big challenge with AI features generally, regardless of how you host it. If you self-host it on Kubernetes, you have the most flexibility in reducing costs, but also the most complexity. So who runs applications here other than microservices on Kubernetes? Like who runs databases or, yeah, a good number of people. A lot of people tend to run stateless applications on Kubernetes. That's sort of the default that people run, but it's flexible enough that you can run stateful workloads. You can run AI models. One big difference, I guess, between a typical microservice and an AI model inference server is they're large. AI models are really, really large. The one I was deployed a couple of hours ago, the container size was 26 gigs. And even the Java applications that our company goes and builds are nowhere near that size. So that's huge. Also at startup, a lot of these things will go and download the AI models from some model registry. They're usually big, in the hundreds of megabytes or gigabytes. And the other big difference is GPUs. So usually when you schedule things on Kubernetes, you specify how much CPU you want, how much memory you want. Now you have to think of another factor, which is GPUs. And GPUs are rather expensive. This NVIDIA stock price, again, taken earlier today. There was a big dip yesterday or the day before or something in NVIDIA stock price. But you can see they're making a lot of money out of this. They've got nothing to lose. Everyone's using their hardware to run all this AI stuff. They're also scarce, so they can charge however much they want. We are having to tell AWS forecasts from a long time in advance about GPU usage that we're expecting, and they're in a lot of cases they're telling us, no, you can't do this. In 6 months' time we won't have that capacity in that region. It's not great. And as every month goes past, a new model comes that requires even more resource. It's getting a bit painful. So we can't go and run one model for every GPU, or we need to be able to share GPU resources. And some models require to run using multiple GPUs. There's a lot of scheduling, interesting things happening out there. Now, I mentioned in this slide pod startup and readiness time. Why is that important? So if we want to use AWS and Google and Azure's Spot capacity, if we can get GPUs on Spot, then we really need to be able to start these things very quickly. Otherwise, we're going to have a bunch of dead time while we're getting requests coming in and we can't go and serve them. So the stuff in the previous slide I mentioned with regards to container size, model downloads, they all contribute to the pod startup and readiness time. If container size is 27 gigs, that means your node is going and downloading that 27 gig container from some registry. Hopefully you have it cached on that node. Maybe you don't. So that's so optimizing that down is really, really important. Now, NVIDIA likes to make things easy for developers. They go and bundle every single thing into their reference containers and libraries, such that you're downloading for every single NVIDIA card in existence when you only need the one that you're actually running. So Hugging Face, for example, has an inference server on their GitHub that has optimized that down, but that only works for text embeddings. It doesn't work for all types of models. But that kind of challenge is usually a challenge that the platform engineers need to work on, because the ML engineers are working on the actual model. So there's also parallelization issues in things like container D when pulling the different layers. It doesn't go and pull them in parallel. There's an open PR. Anyone wants to review and work on that, contact me and I'll send you the PR. There's stuff for there's stuff everywhere in the stack. There's people experimenting with using BitTorrent to pull models off different places. So yeah, there's a lot of nice opportunities, but if you want to run things at low cost and hopefully below your revenue numbers, being able to auto scale cost effectively is important. And I think Kubernetes gives us the tools to do it. We're in and the CNCF community generally, but we're still early days. There's lots and lots of work left to get it to get down to areas where optimization won't help that much. So this year, I think in the summer, the serving working group got created at in Kubernetes. There's a Slack channel. There is also a GitHub repo for the serving group, and one of the areas they're looking at right now is about making auto scaling effective, and about container pulling and startup time improvements, etc. People interested, join. There's a weekly meeting. If you can't make the meeting, there's recordings. There's also the Slack channel where lots of stuff is discussed. If you like optimizing things, there's lots of things to optimize, and you can really help out. There's also a really nice white paper that the CNCF made. I didn't put the link here, but if you go and search for CNCF AI white paper, it's hopefully your first link on Google or other search engine. It talks about some of the challenges with all parts of AI, not just the inference serving that I've been talking about today. So we use all three at WebEx. We use the API provided by third parties. We also use AWS SageMaker. We actually did a talk at reInvent last year with the SageMaker team, talking about a few things. And we also self-host models. Models we kind of self-host are both LLMs as well as as well as other ML models. So, the API, third-party API, great for experimentation, playing around, proof of concept, low traffic if you're not expecting this application to take much traffic, or you have no clue at the beginning whether it's going to. Is it really worth putting a lot of effort into infrastructure management early on? Probably not. If the models are available there, you can go and use it, see how your feature takes in the market, and then as you see your costs go up on the pay per use, you can go and try and optimize and bring it to Kubernetes. But really the message I want to bring here is there is even though Kubernetes and a lot of the well-known CNCF things are premature, and there's potentially a high bar to entry when doing things. This is very, very new. There's lots of opportunities to help, and if you're interested in performance, interested in just helping out, please do. Okay, questions?
All right, thank you very much, Sahir. Looks like we have a couple of, I think I saw a hand over here, so we'll start with that, and then we'll do a couple of questions here. Okay, I'm sorry, that was a little bit louder than I expected. Would you like this microphone?
So firstly, Zahir, thank you for the invite today. It was because of him that we came. I was interested to attend actually because of the options within your field. What I wanted to ask is, as a service provider, it's not directly related because I have no idea what Kubernetes is, or a lot of those words, but because my husband works on the tech side, I understood a little bit. What I wanted to ask is, what is the crossover in using these solutions for service providers, for small businesses, in your experience, very briefly, that you can think of, maybe like the top 3 things that you can think of? Sorry if that's too broad.
Yeah, it's gonna happen. Try it.
It's on.
Okay. It's working. That's a very good question. And I'll get back to you on it. I think that's
All right, let's take one of these questions. So the first question, how much of this really uses AI? I've seen many features that have been part of WebEx for 5+ years. The only changes are writing AI next to the feature.
so the ones I had on the slide all use some kind of AI. We may not have advertised it as AI because AI was not the hot buzzword that it has been for the last few years. So yeah, all of those are AI.
When thinking about revenue gains from AI, have you considered productivity gains as a measurement? And if so, how would you measure that?
So I'm not a business person, but quite a lot of those features that were on the WebEx AI slide are productivity or features to get you productivity gains. The summarization, the what happened in the meeting while I stepped away, meeting transcripts, so you don't need to watch a meeting. You can read the transcript and decide, hey, do I really want to watch the meeting? So you save a lot of time. Then there's some probably less obvious ones. There is one where you can get the WebEx app to go and change the thing you're typing to somebody else, so that it sounds more professional. May not seem like a productivity gain, but it may make your conversation work better and reduce any friction or any time. Yeah.
Okay, excellent. This one's come up. Are you using your own models or open source models?
Both.
We have quite a lot of ML engineers in Cisco and in WebEx specifically. In WebEx specifically, we have quite a lot of audio and video expertise. So I mentioned the WebEx AI codec, the background noise reduction. So I'm not a salesman. I use all of these things: Zoom, WebEx, and Microsoft Teams weekly. That one feature in WebEx, the background noise removal in WebEx, is so different to the so much better than the other two's algorithms that I really miss it when I go and use Zoom or Microsoft Teams. So I'm not trying to sell WebEx, but if you're in a WebEx meeting, try it. I think it's on by default now, but give it a go. See if the other end can hear your son talking if he's talking to you while in a meeting, and building work, etc. None of that gets transmitted.
Okay, we have a question in the far corner. Take that one and try and tackle one or two more of these, and then.
Sorry, I just wanted to know about the if you could expand on the 27 gig container. Why put the model in the container and not pre-prepare it in a faster sort of storage system such as an SSD, and use like a faster RAM type?
Yes, that's a good question. This particular 27 gig container is not something running in production. So it is a proof of concept that one of the teams is working on, and it goes and pulls in PyTorch and a whole Ubuntu distribution, etc. It's not yet ready to go production, but it's easy for those developers because they have all the libraries that they ever think they'll need. But yeah, using faster storage options. We've been looking at like S3 Express One Zone, for example, in AWS. We've been looking at baking some stuff into nodes, so that when nodes scale up or new nodes come up, it already has the big files on there that is expecting. So there's lots of those kinds of optimizations that we're looking at.
All right, we're going to wrap it up there and move on to our next speaker. So round of applause, please, for Zahir. All right, our next speaker of the evening is Lewis. So stage is all yours.
Not a microphone.
Do I have a microphone? We're working. Hello, everybody, and thanks for being here. And thanks for everything, really. So my name is Lewis, and I'm going to talk to you about moving the CI/CD aspects of your development closer to the developer. So first things first, my name's Lewis. I'm a platform engineer at Akamai. I've worked at a few different places, including Ondat, that I know some of you are familiar with, and Starling Bank. Ondat was actually acquired by Akamai last year, so there's a number of us working within the Linode part of Akamai. I like automating things, cloud native stuff, and getting developers to do as much as possible in the most pleasant way possible, really. So the project itself is object storage for a tier 2 cloud provider, that being Linode. It's completely greenfield. If you discount the fact we're going to have to migrate a load of data from the old one at some point, which is a blessing and a curse. We knew that we were going to be running microservices on Kubernetes, but we had no dev environment, no infrastructure, nothing. So that's great because we can build something cool, but we've got to build it. We've reviewed a few different tools for the dev environment. That was our first priority, as we had a dev team that were itching to start developing, but absolutely nothing for them to do that with. And we settled on a tool called Tilt. So Tilt's not the main topic of this, but for context, I'm going to run through it. Has anybody in the room actually used this tool? Excellent. Okay. So what Tilt does, it sandwiches itself between your code base and a development Kubernetes cluster. For this example, we're going to be using Kind. You can use pretty much anything. It will monitor your code. It will build it for you. It will build the images. It will push it through to a development registry. And whenever you make code changes, we'll do that process all over again, meaning you get super fast feedback on your code changes, which is really quite nice. So, right. I'll demo this relatively vanilla dev environment first of all. Cool. So that'll give me a Kind cluster and bring up Tilt on top of it. So this is the example repo I prepared for this. It's pretty simple stuff. We've got I can indeed. Unfortunately, I'm using a French keyboard layout and it doesn't like the keyboard shortcuts, so I have to go all the way into the view. Is that better for everybody? I mean, this is not a particularly challenging piece of code, but so yeah, I've got a very simple Go service that just posts I'm alive every 2 seconds. I've got a deployment, and I have an overlay for the development environment. All we're doing here is reducing the number of replicas. Nothing particularly challenging. Oh, good. This will work. I've been hacking around with the Tilt code base today, so it takes I think there's obviously something which is ever so slightly different to the downloaded binaries, but anyway, we're up. So here we have my little service running, and if I go into here and make a small change, That's been picked up. And shortly, we'll see my new feature. Excellent. Cool. So that is Tilt. But
with the compiling code.
yes. What the just for that example, that was Go. Cool. So yeah, Tilt's a cool tool. Gives you super fast feedback when you're developing microservices for Kube. It's great, but at this point, we had a dev environment for our team of developers. They are able to start working. So we turn more towards the next steps. At this point, we still didn't have an actual environment to deploy to. There are a number of reasons for that, but that's not, again, that's a little bit off topic. So we began to look at the next steps. Now, it occurred to us that you can use this tooling for anything that runs in Kubernetes. We knew that we were going to be using Argo CD to deploy our microservices later down the road. So we began to experiment using the combination of the two. Now, Argo CD generally will hang off of a Git repo itself. And I saw there are a number of platform engineers here, so I'm going to guess that there's going to be a fair portion of you guys that have at some point had to deal with a development process that involves lots of test commits or something like that. GitHub Actions comes to mind. It can be tedious, it can be painful, and it's slow as well. So this should work around that. Bear with me 1 second. I'm just going to instantiate the next environment before we get there. Excellent. Okay, so for instance, I have been in a situation before now where in order to test an aspect of, say, a CI pipeline, I've had to actually physically commit some unfinished code into a branch and push it up to GitHub, for instance. There are tools that exist to try and work around this, but personally, in my experience, I found them to be either feature incomplete or for their behavior to differ in some way. So where are we? There we are. So yeah. So what we came up with was combining Tilt, Argo CD, and for the Git aspect of this, a small Go-based tool called Gitty to effectively create a dummy Git repo in cluster. So the way this works is that Tilt will schedule Gitty and Argo CD on our development cluster. Some additional scaffolding that is in the repo will create a dummy repo in the Gitty instance and copy the content of your actual repo across to that. We have some customized overlays on our Argo application manifests to define any of the differences between what we expect to be in production and our dev environment. So think things like the repo that we're going to be pulling from, for instance, in this scenario. Tilt applies the application manifests to the repo. Bear in mind, we still get that benefit of the fast reloads. So if we're developing a relatively complex application that has a bunch of different dependencies or whatever, we can bring it up and down very quickly locally. Argo CD will pick those up, bring up our applications, and then we can simulate subsequent Git pushes to the repo, effectively deployments, I suppose, in this scenario, all locally on the laptop. So this has now come up. I do this. We have our Tilt interface. We've got Argo CD that's been installed here. We have Gitty as well. All right, that's a timing issue. That didn't run cleanly, so I'll just sort that. All right. Just excellent. So come on. Oh, good. Oh, it's hidden underneath there, isn't it? That's what's going on. So here we have our Argo CD instance running locally. Right, this application's unhappy because the initial push failed initially, I think. There we go. That's coming up. So we can see that Argo CD has successfully deployed our application there. And as I mentioned, the customize overlays part of this. This is what we're pretending is a production-ready Argo CD application here. We can see it points to a definitely real repo on GitHub. But in our dev environment, we've overridden that to point to our in-cluster repo. Now, I'm gonna make changes to the next example because I think it's a little bit more interesting. But yeah, here we have the ability to configure our Argo CD effectively completely as if it were a production cluster with a few changes that are documented here, and iterate fast upon that, really. Right. So we've at this point gone from step A to step Z, I think. There's a fair chunk in the middle. Generally, one doesn't go directly from a dev's laptop straight into a production cluster. There's testing, security scanning, anything that falls within the realm of CI. Now, if you run your CI within Kubernetes, there's nothing stopping you from taking this exact same approach and doing the same thing. You still need to have a dummy Git repo in order to make it clean, I suppose. But yeah, so I'm going to be using Argo events and Argo workflows in combination with Gitty and a really cool tool called Dagger. Has anybody here used Dagger? No? Okay. What about Argo events or Argo workflows? Okay, a few of you. So Argo events and Argo workflows are not a CI platform. They're a thing runner, but they can be used as a CI platform. Dagger is it's kind of like an SDK that you can define your CI flows in. So I'm going to be using Go to write my CI flows for this example. I believe it supports TypeScript as well. It's a really cool tool. So the way this is going to work, we have Tilt, as before, scheduling Gitty, Argo workflows and events, and Dagger all on my cluster. We're going to create a dummy repo as we did for the first example. Customize overlays, as before. And it's more or less the same flow, except we're doing a different thing. So if I go over to here, that's up and running. Let's fix that. Make sure that that's failed as well. This has been super reliable all day. And as soon as I'm doing it live in front of people, of course, it falls over. Classic. In a minute, the sound system will go mad and deafen me, I'm sure. Right, so there's no authentication on this UI, so we can go straight in. Cool, so this is the other workflows UI, all running in on my laptop. So as before, we've got some base manifests. We've got our dev overlays that define all of the differences between a real environment and what we're doing here. I have my actual CI flows defined here. This is also written in Go. Which I really like. As a platform engineer, I have to deal with far too much YAML, in my opinion. So what I'm going to do is I'm going to make a small change to our little application again. I'm going to say word world. There we go. No, I want my browser. There we go. Let's have tilt. I'm going to simulate a git push to our dummy repo. Well, it is a real push to the dummy repo, but it's not adding to the git history on my real repo, as it were. That's gone through. And now we have a build running for us. That'll take a little while. In the meantime, I will show you the rest of the environment. So the way this works is that an event is triggered via a webhook internal to the cluster. That then triggers a workflow within Argo workflows. We have this little CI container, which is a helper that will parse the payload of the webhook, transform that into something which is more standardized, so that, for instance, if you had GitHub for your actual repo and Gitty for this, that would standardize that so that you could have exactly the same flow for both, and gives it to Dagger in a nice, easy to parse format. I can develop any aspect of this flow, be it the webhooks, be it the CI helper, absolutely anything, and Tilt will rebuild that, schedule it on the cluster for me, giving me super fast feedback. And as we can see, this build is happening as we speak. Where this is a brand new cluster, the Dagger engine is got a cold cache, so it's a little bit slow on the first run, but we're getting there. Right. I'll come back to that in a minute. So that's all I've got on the demos. That build is going through. It will push its container and work. I'm happy to prove that if needs be, but I've already done it 10 times today. Yeah, so if you take anything from this, I think it should be that tools aimed at developers aren't necessarily only for developers. Us as platform engineers, we can utilize this tool set and basically work faster. So yeah, and that's all I've got. Any questions?
We do have some questions. First one, what issues have you run into with this setup?
It's certainly solved more issues than it's created. A few of the bits around the scaffolding can be a little fiddly. Tilt in its current form doesn't play very nicely with the Argo manifest, which is why I've had to add some additional scaffolding around it. We have also recently hit some pretty hefty resource contention issues, meaning we've had to move away from running the local cluster on kind, and we've moved on to a beefy engineering VM instead on a per developer basis. But I would say that's about it for the most part.
Is Tilt similar to Scaffold?
I believe so. My experience with Scaffold is considerably more limited. I seem to recall there was something around how one defines your Kubernetes resource in Scaffold that just simply didn't fit our use case. The great thing about Tilt is that it uses exactly the same manifests, but barring any changes you apply with Customize to avoid things like resource contention. So yes, I believe the answer to that is yes, but they're different.
Take a question down here.
Thanks. Congratulations on building this. It's nice to see. I've tried to do something similar, probably tail end of 2017, early 2018. The tools back then were like Minikube and GitLab Community Edition. I was wondering, has the changing tool set made your life easier? And do you see this becoming kind of more approachable as laptops get beefier in future as well, to be able to run everything fully local for developers?
Yes, I do. The changing tool set has definitely helped. The fact that there are now relatively easy to use tools that can do the job of the CI platform, or actually dedicated CI tools, the whole thing being based around Kubernetes, has made this considerably more, I suppose, plug and play in that kind of environment. When it comes to the beefier laptops comment, which is a very, very heavy piece of software in its own right. Yep.
Sense that by the time the code got off the laptop, it was guaranteed to work.
Yep.
But it was such high friction
that the developers really did not like it.
So I'm not finding this to be particularly high friction, I have to admit. I do think the fact that it's not basically it's not GitLab. GitLab's a great product, but it is very heavy and not really designed to run in that way.
How do you ship it to the
How do you ship the configuration? Do you make it, how do you, because part of it is the complexity of actually doing the thing. And if it's just a single command, it's okay. Whereas if they've got to sit there and wait for 15 minutes while it does some arcane things they don't understand, then they're like, platform engineering, get it off me.
Fair. So we have a bunch of prerequisites that are documented in the repo. We're talking things like the tilt tool itself and anything that the scaffolding around it requires. It's a relatively long list. It should really be a script that does it all for us, as we're all using the same version of the same OS. I think partly it is. But once all of that is done, it is simply a case of a single make target, and it comes up. As the set of microservices that you have, or whatever it is you're running, grows, it can take a few minutes to come up. That gets better with hot caches. It also gets better if you scope down exactly what it is you're running to whatever it is you're working on, plus its dependencies.
Like you've seen with Git here, there's this growing trend for application patterns to go to be a single Golang binary.
I mean, we're very lucky in that respect, in so much that everything that we have been developing, with the exception of our custom envoy, is written in Go, is very lightweight. So the compilation time for all of these various things is basically not worth talking about. Yeah, other than installing a bunch of tools, it's a make target. Yeah, that's pretty cool.
Does this workflow mean that you can send your work to your CI/CD tool without having to commit your code?
Well, I suppose kind of, in a way. You're effectively creating a replica of your CI/CD tool on your laptop and then committing it to a dummy repo. So you are still committing it, and it is still going through whatever flow you've defined, but that doesn't mean it's actually in your real repository. So for the purposes of functional testing or whatever other flavors of testing you want to do, yes. But I'm not quite sure why you'd want to do that. If you spent all this time developing it, why would you not push it through to your repo? Yeah, perhaps there's more context required here.
The implication was, yeah. So the implication with my question was, is there a security hole there where you could effectively get some code past whatever security checks you have in your CI/CD tool normally?
Right.
Is there
Okay.
a bypass there, basically?
Okay, I understand now. I don't obviously see one. I think one would have to be a little bit careful around credentials for things like container repositories and whatnot. But it's no different from a developer building a container locally and attempting to push it. So I don't see that it makes it any worse. I see that it just gives you a more representative way of running that flow local to your own environment.
Okay, last one. We have an in-house image build system. Is that something that can be integrated with Tilt? Well,
so obviously I know nothing about the in-house image build system. However, Tilt does expose something called custom build, which should allow you to do that, yes.
All right. Okay, we're going to go to the break now. So round of applause, please. Thank you very much, Liv. Okay, so we're going to take 15 minutes now. Please help yourself to more drinks, more pizza, if there's any left. Use the toilets, end of the corridor. If you are leaving now, please remember to return your key fobs as well. Otherwise, I'll see you at 8 o'clock. Thank you. Nice job. Very good.
It's a cool setup, isn't it?
It is quite cool, yeah. It's I'd not heard of Tilt before. Quite interesting, yeah.
Very heartening to see you carry that on. I've tried for months to convince our developers that this would provide better quality code.
Thank you very much for the introductions.
Thank you so much for coming along.
That's all right. Yeah, yeah.
I know it all was a little bit funny last time.
That's
so,
okay.
fixed it.
Fixed it.
Yeah, I'm glad you're here.
Yeah.
I'm very glad you're here.
Thank you very much.
All right, take
Catch you
care.
later.
Cheryl.
Hello, you
I'm
made
Michael.
it.
Yes,
You
I
made
did.
it. Excellent. Have you're doing your
Presentation on your
yes,
left.
yes,
That's
yes,
correct.
yes.
That is correct.
Let me draw that up. So pick that up. So you make sure that it.
Is that like a clicker that people use, or do they just?
Yeah, basically you can find your YAML.
I will use the left.
And if you your file.
The thing that plugs into the stick.
Oh, I see.
So
Yeah, no worries.
You had to screw around with virtualization providers all the time.
you make it okay? I know you said you had a rush. You had a meeting that finished.
Oh yeah, absolutely fine. Everything was planned to the minutes, which is ironical because I will tell you how you can't plan for anything, but
I think because I've got the screen share.
Oh yeah.
See if I can. I just need to grab the list.
Sure. This. So this is the good one, right? Microphone.
Both okay.
I mean, one of them was quite. Oh, one of those is bad.
The orange one was.
All right.
That was.
I mean, yeah, that was the screaming one, but there was also like a quiet microphone and a loud microphone. Test. 1, 2, 3. So this is a good one.
We have clip-ons as well, which no one ever typing and doing a thing uses a clip-on, and I always afterwards think, oh, I should have.
Yeah. Well, luckily, I'm not typing anything today.
Yeah, that was the first time that's ever happened.
I mean, this was just feedback.
Yeah, but it was very strange sounding feedback.
Yeah.
It was like.
Yeah, usually it goes like.
I know, it was quite shocking.
I think maybe they're like just doing some processing, like on the microphone that kind of warps the sound, maybe.
So let me just make sure. Is it the one?
Yes, that's the one with the meme at the beginning. Yes.
Let me just send.
Charges always say, oh, it's not our fault. It's the highest, the cost of GPU. Now, I mean, remember the open source carrying out shares of fund. Now, we had a meeting with the Parker, now release new hardware. We're going around.
Hey, this is what I did.
The stuff we test with these, which Miller Packard and orange with subsequent GPUs risk processors. And you doesn't notice any difference. The processes were so easy and the costs were so low. But the problem is, Miller Packard was telling us that a lot of the development for Spark is based risk-based processors. I've now moved over to GPU. Because the cost of bringing them back again will be so, so catastrophic, and so the open source community help. What NVIDIA is doing is kind of
I can eat it. I'll eat it. Yeah, that's fine, eventually. Some of this is
it's like your blogs on the street cannot afford. Been handed the cost downstream. He wants to rent back application business there. You can see that. You know the big oh yeah. It is a big problem, but we were doing about the resources supply.
everybody knows this stuff.
When the rent stuff like that. But then again, there's then that move where the original risk processors are vendors, now very local, so the cost of pulling the developers are back into that. I don't know what to say.
Yeah, anytime that I'm at speak. Yeah, it just takes a training.
Probably person might be needed in the long term if they continue to get that. That's not that's a category for the AI. Well, I mean, where's that one? And from what I've seen, the system probably completely diffuses. The problem is attacking the developers. The way NVIDIA goes about tying down and something is also happening.
Just a little nudge, started a meeting, created a doc, but it is about time. And it's genuinely quite proud of it. Not that I contribute to it for lots right now, but this that moment is like, hey, I remember these things.
This is where it's yeah. They're actually the company that
you know what? Second hand, fine.
If they go with the access, well, we did a process using that they decide to go down. Kind of the hyperscaler and some of the state now. So basically, strain on Irish domestic airline. So it's over the years and it's been very perfect now. So they didn't have to run it from their area and So guys, I can relate to it, but the one that really caught me was the debate about non-microservices deployment. The majority of deployment of Kubernetes, that's one. It's easy to say that, but I can get the opinion is I have a location where I want to tell somebody I want to be on the actual office of that. Oh yeah.
For me, it's just fun. This is the kind of event that I like to go to myself. To learn about new things, see what new tech and the arts people are doing. And it also go to the pub and chat to people. I always like, I want to do the kind of event that I would go to as a speaker and also go to as an attendee.
Yeah, I really like it. The tech's pretty good, and the audience is physical.
Yeah, yeah. I like this. I really like this. And I'm quite. I want to encourage speakers to talk about topics that are going to be interesting to the audience as well. So I'm quite picky as well about that. I like to welcome people who've never spoken, but I want them to give a talk.
Yeah.
It's the right audience. Sometimes that doesn't always go in, but it's okay. I think we're nearly there. We've got all right. Welcome back, everybody. Thank you for coming back in promptly. I'm now going to hand it over to our third speaker of the night. So, round of applause, please.
Hello, hello. Hello, lovely people. It is so loud, this one, isn't it? No, that's fine. That's fine. I'll just keep a distance. Hello, everyone. My name is Michael Panin, and I will start with a meme today. This is a very unusual presentation for me. Usually, I come up on the stage and I give a talk about something cool that I have done that shows how proficient I am in what I do. Today is not like that. Today, I'm going to tell you how terrible I am at planning. And I'm just hoping that this is an experience that you might share with me. Issues with planning. So, does it work? It works. Who am I? My name is Michael Panin. I've spent 10 years in game development. I don't think that I'm like the best game developer ever, but I think like I'm a decent professional. And what do I need to do? All right. I've been an engineer at a tiny 6 people small startup. It doesn't work. How do I? I've been a tech lead at a 12 people startup, at a 50 people startup. And now I'm a senior engineer at a big tech company. And everyone I have worked with struggles with estimation. Everyone. From juniors to world-class developers. My colleagues and my friends alike, including world champions in competitive programming and PhDs. It doesn't matter how smart you are. I could be considered by some a successful engineer, and I'm pretty terrible at estimating. Really, really terrible. And today, we will understand a couple of things. Why estimation is inherently inaccurate. What estimation rituals that we all go through are actually for. How long-term planning works if our short-term planning doesn't, because we do see companies succeed and kind of meet their deadlines. How does it work? And ultimately, hopefully, we will save your company, your product, your career, and your sanity. Estimating tasks, ladies and gentlemen, non-binary, everyone, is difficult. But I'm not here to teach you a better way of estimating tasks. I'm doing a poor job at that myself. I'm not here to tell you to stop estimating either. Ooh. But still, this point that it is difficult is very important to me. Why? Why is it important? Because time estimation is something that we all do. It is a common habitual ritual that is perpetuated in every single company. Well, maybe not every single, but most of them. Misunderstanding the meaning of that ritual leads to actually grave consequences, starting from very simple, like intense negative emotions where you're not meeting the deadline. Spread of bureaucracy. Sometimes the leaders decide that they need to be better at planning, and so they need to measure more and need to spend more time on estimating. And as a result of that, we get worse products because people spend too much time estimating and too little time working. Failing careers. This is a real one. I had a leader in one of the companies that I worked at who got fired because of that. Failing businesses. One of the startups has closed because of that. And it all is worsened by a widespread misconception that a professional is able to accurately estimate tasks. At this point, I guess I would like to ask the audience if anybody in the audience thinks that they themselves are quite capable of estimating. Anybody? I was hoping to find at least one person, but all right. I guess my point stands. And if you look on the internet, the worst thing is there are articles like that who tell us, oh, there are just 5 simple steps to nail software development time estimation. 1, define the project's complexity, give ballpark estimates, build and estimate the scope of work, add a risk buffer, make room for time eaters, and everything will be wonderful. You will estimate things correctly. While in reality, it just leads to you sitting at the computer at 2 a.m. in the morning because the deadline was yesterday and you're still nowhere near with the tasks that you are doing. So why? Why is it so difficult? Well, it all starts with this weird thing. When we're estimating tasks, we're rarely talking about distributions at all. We're all saying, yeah, like I can do this task in 2 hours. I can do this task in 1 day. And this is a simple reality that we all kind of know underneath it, but we don't speak about it too often, that this is like a probability distribution. We talk sometimes about risks, and that's kind of somehow there is like time estimate and there are risks assigned to the task. But the biggest problem is that the probability distribution of time required to complete a task is not what we expect it to look like. If we read Mike Cohn, quite a popular person, in his book, he says that this is what the distribution kind of looks like. For a 1-point story, it is like a Gaussian nice distribution with like 12, let's say, hours in the middle of it. The nice thing about a Gaussian distribution is that it has a medium tail. If you are predicting the middle of it rather accurately, you will not be too far apart from whatever the real answer is, whatever the real time of the task is. The bad part about Gaussian distribution is that it is not a distribution that predicts a time spent on a task. There have been studies, and they're showing that it is much closer to log normal distribution. And this is a kind of distribution which has a really long tail. That means that whenever you have like your estimate, you have estimated, like, let's say 100 hours to spend on this task. And it might take you 6 times more. And it is actually quite a likely result because of a long tail. What's even worse is that the mean of this distribution is somewhere over there. That doesn't feel intuitive, like an intuitive thing to us. The mean of this distribution is around 160 hours, whereas a mean is the answer that we should give to people if we want all of our estimates to kind of add up and all of our errors to cancel each other out. The median, which is the number that we want to give if we want to be wrong 50% of the time, overestimating, and 50% of the time underestimating, median is around 100 hours. And the mode, which is something that we actually learn because this is the most frequent time that we see for that type of task, is around 40. So like when someone comes to us and asks, how long will this task take? And we say like 40 hours. The correct answer, as in a mean, would actually be like 160, which is why you see all these managers adding like 4x buffer, which is a lot, but that's why it's a lot. But even then still, because of the long tail, it might end up taking like 600 hours easily. Moreover, it is implied that there are distinctly separated distributions. 1-point story is a Gaussian with a mean at 12 hours. 3-point story with mean at 36 hours. That's just reason, right? But when we look at the research of different people, and there's not too much research about that, but there is no distinguishable difference between 1 and 5 story points. Again, some other research, again, no distinguishable difference between 1 and 5 story points tasks. And I found only one piece of evidence that there is any difference between 1 and more story points tasks. And it only worked when the task size, the maximum task size, was about like 120 minutes, 2 hours. For how many of you do you plan your work with like 2 hours granularity? This is crazy. I have no idea where they got this data from because it is anonymized, of course. But I don't want to work in that company, if I'm being honest. Yeah. So, and still, they are somewhat separable, but not really. The room for error is plenty. Why do you feel like you're always late? That's also a good thing. If we take a log normal distribution
and we plot a probability that you are right now in a task that takes a specific amount of time, this probability declines very slowly. So like you might be right now, the probability that you're working on a task that takes just 1 hour and 4 hours is almost equal. So you're almost always late, in a state of being late. And the big question for me is, why does the distribution actually look like that? Can't we do anything about it? And this kind of goes to the question that was in the polls. Like, how often do you have a clear and accurate picture of the code that you will write? I think it's quite rare. We all start with a blurry vision. We use kind of diagrams to make some sense of it. We use code to touch the reality of the task for the first time. Only when we start coding do we begin to understand what the task actually was. We rewrite code and progressively uncover what the task actually was about. Think about it. Like, even if the task was huge and you've written like 600 lines of code, it's just 600 lines of code. You could actually write that like in 15 minutes, probably, some type quicker than that. Most of the time was actually spent on discovering what it is that you actually need to do. Okay, all right, but you might ask me, like, what about tasks where everything is clear from the very beginning? And there are tasks like that sometimes. And they're called routine tasks. And we as software developers do anything to get rid of them. We automate. We write a library. We invent a language, or maybe we Google a library or Google a language. We strip our world from non-creative tasks. This is what we do as software developers. And all that we have left are these tasks that we cannot estimate because they're just too complicated for our little minds. So coding is an iterative, it is a creative process. Just as an artist doesn't know what he or she will paint before they finished with their painting, we don't know what we'll write. We just gradually reveal it. And the moment that we understand it completely, we could finish the task in 15 minutes because it's just 600 lines of code. How difficult could it be to type it up? Actually, like, did anybody delete their code by accident ever? Did that happen? Did you find it much more easy the next time to write it again? Right? Yeah, of course. Oh yeah, that's good. Not always, but yeah. So, but like that also begs the question: what in the world is a completed task? If when we're writing a task, we don't know what a completed task is, and until we kind of complete it, we don't know what a completed task is. What is it? What is it? What is it? And it is always some kind of trade-off. This is an experiment run by a YouTuber, Nerdforge. She painted a picture of a knight kneeling in front of a big tree at dusk. And she spent 1 hour, 10 hours, and 100 hours. And the difference between 1 hour and 10 hours is quite drastic. Like, there is a significant visual fidelity improvement. And 1 hour seems like a not completed task. 10 hours seems like kind of a completed task. But the picture, the drawing at 100 hours, it's just stunning. It's next level. It's much better. And I would like to posit that it is kind of similar with the code. It is quite often that we are just submitting our code because there is business need that we need to fulfill. It is not finished, not totally. We all know it inside of us. It maybe not passes all the tests, or maybe we didn't write all the tests, or maybe the architecture is not perfect, but we're always trading something off. And we sacrifice quality. Sometimes maybe like the button that we've added like 100 milliseconds to the page load time. Well, who cares? Bugs, feature cuts, worst of all, tech debt. If you're an artist, an actual artist, and you paint a picture, if it's bad, but it doesn't affect your future paintings. Unfortunately, that's not the case for us, for software developers. We're doomed to live with that. And we always make sacrifices. When we mark a task as done, it's basically we're saying, I don't want to spend more time on it. I feel like this is enough, and I cannot be bothered. I have 100 more tasks in the backlog. I want to start doing those. And that's a good thing. I think that's very important. Rick Rubin said the work is done when you feel like it is. About artists, of course, and musicians. I think that still works with us software developers, but we need to add a little remark that QA also needs to agree on that. And that's kind of how they push back if we're too lazy. And that is why we're so bad at estimating. I think it's just that simple. We don't know what it is that we're building before we've built it. And therefore, it is very difficult for us to tell how long it will take because we don't know what it is that we're doing. Now, this poses a big question. If we're so bad at estimating, why do we estimate? Everybody does it, every single company. Well, maybe not. Does anybody not estimate their tasks? Is there everybody? All right, everybody estimates. Yeah, I think that short-term planning is a ritual. And it's not a derogatory term. I think ritual is a good thing. Because when we look at a task through the lens of the time that is required to complete it, we start actually noticing, for the first time, really noticing the reality of the task. It dawns upon us. We collect ideas together with an optimal solution. We kind of talk to each other. How could we do it quicker? And that's actually a useful part. Even if we don't know how long it will take, we still can take like a long route and a shorter route. So that's a useful thing. We also establish soft deadlines. This is very helpful because otherwise we might spend forever. And we do need to deliver it at some point. And we find a sense of safety. I don't know, we don't talk about feelings so much in IT world, but we are all human beings with feelings inside. And this feeling of control, of knowing what lies in the future is nice. It gives us hope and it gives us a vision of the future. It doesn't matter if this future will arrive next week or in 1 month, but it's just nice. We know where exactly we're going towards. That feels pretty good. But there is obviously a dark side of control. Through short-term planning, we create this illusion of control. It's not real. We've just sacrificed a lamb. It will not affect our crops. If we hold on to control too tightly, we will create suffering for everyone. Quality will decline, anxieties will rise, and creativity will die because you're just thinking about how not to get fired. It's a lose-lose situation. I was once in a company where I was asked, me and my team were asked to deliver an MVP for a game within 3 months. I knew it was impossible, but the previous tech lead estimated it for 3 months. And the higher leadership pushed on me really hard. And I really had I had choice, of course, but I wasn't brave, I guess, enough to really stand my ground. I did tell them that I don't think that it's realistic, but we still tried to get MVP on time. And what happened is that we got MVP on time, technically, but all the features were so terrible in quality that we basically had to rewrite everything from scratch. It was terrible. It didn't work at all. Yeah, and that's pretty bad. That's 3 months wasted. So art doesn't get made on the clock. We can't just say, yeah, do it by then and expect it to work like that. But it can get finished on the clock. So we do estimate to create this motion, this soft guidance towards something, so that once we feel like we are close to completing the task, we can look at the clock, see if we have any time left. If we do, maybe we can spend it on doing the task better. If we don't, maybe it's time to just hit submit and hope that QA will not notice anything. And QA processes are there to push back on these deadlines in case somebody is like really anxious about meeting the deadlines. QA is there to help us, to say, look, I know you've hit commit on time, but you gotta redo it. How does the long-term planning work? That's a big question. Like I've worked in companies and they've had real-world deadlines, and they successfully met those real-world deadlines, and they've released their games on time so that the promotion will be in place. Everything worked. But they're there just to guide us on how much quality or quantity we're willing to sacrifice in order to get like this thing that we really want. they don't actually define the scope of the things that we need to do in order to get it. So yeah, there should be, if we want something really bad, maybe we should cut almost every feature from the app and just release just the bare minimum. That's how it works. We just throw away stuff that we didn't complete on time. And it works like that in every company. And then, like, if somebody is really smart and really good with politics, they will say that we've hit all the milestones that we needed to. But in reality, there were feature cuts, always. And reality must be allowed to push back. Otherwise, you'll spend 3 months on a game that nobody will ever play. No Man's Sky. Yeah, if they just had more time. Well, they actually did have more time. And I don't know, how many of you know about No Man's Sky? Yeah, lots of people. Good. No Man's Sky is a game. It was very hyped. It was released in a terrible state because of them not being able to meet the deadline that they've set for themselves. And everybody was really angry at them. But then within the next couple of years, they were working on this game, making it better. And guess what? It's a really good game now. It has really good reviews on Steam. So all they needed was just time and to not succumb to the desire to, just publish on time. Yeah, I guess Cyberpunk is a good example as well. So takeaways from this. I hope you like my Brett green color on the top. Takeaways. Remember that estimates that we give are pretty inaccurate, and that's fine. Notice when your org gets overly focused on estimates and too controlling. Try to push back on it if you can. Prioritize getting faster and better over getting more precise estimates. That's what really matters, because planning doesn't work either way. Use long-term planning as a guide for when we would like to have it, or when we would like to have some of these features, and how much we want to have something at that time. But be ready to drop stuff and continuously reevaluate your plans. This has been my talk. The QR code is over there if you want to get the slides. Subscribe on my YouTube for graphics videos, Instagram for poetry, and LinkedIn for, I don't really know why LinkedIn exists, but yeah. Thank you very much.
Amazing. Thank you very much. I will have one point. My very first job was at a consultancy. And in this consultancy, we estimated things down to 20 minutes. Oof. It was stupid because you spend an hour every day estimating a whole day's work. The overhead of estimation was ridiculously high. Anyway, I didn't stay at consultancy very long. All right, let's go to the questions. See if anyone has submitted some questions for Michael. Also questions in the room. Yeah, I'll continue.
Yeah, amazing stuff. I think it's a really good perspective on planning. And I think there's a saying, right, that the process of planning itself is what's valuable, not the plan itself, right? The plan can be thrown away. So I think definitely in terms of like, when you look at large companies, how they use that plan, that's the dangerous thing. One thing I'd say as well is that, and I really want to get your opinion on this, I think it's really important because as engineers, sometimes we can build the most trivial part of the product and it'll take us years. And then there's this really supposedly high value thing we can build in a day. So don't you think it's really important that engineers actually understand the product so that they can work on those things that don't take so long, that they know are actually quite easy to implement, but are quite meaningful, rather than focusing all that time on something that isn't, maybe somebody thinks is really important, but given the cost, the engineering time that's required, maybe it's not the best thing to put your time in.
Yeah, for sure, I agree that it is very important for engineers to understand the requirements of business and where the business actually gets their bucks. Yeah, and for sure, it's very good to kind of, if you see a quick path somewhere, why not try and take it? Just, don't think that it will actually necessarily be a quick path. I think that's the takeaway. Yeah.
I like this question. I'll come to you next, but all nice, but have you managed to sell this to any management, C-level people?
I think that's a very good question. I've just started talking to it about people. It's actually very scary to tell people that you're terrible at estimating. And I felt quite vulnerable today at this stage, and I wasn't sure if I will be judged by the community or not. And I'm happy to see that I haven't been judged. This is very nice. Yeah, but I think that people definitely should talk about it more. And I think that actually C-level people understand this, at least good ones.
If you, your data that you had for the accuracy of points, if a point is a measure of complexity and not one of the size of the work or the duration, then in fact you would expect to see the distribution that you found, because one team, because the measure of complexity is relative, one team might estimate the same amount of work as 70 points and another as 10. And if you use Scrum and then burn downs to work out the velocity, their velocity might be 70 points and 10 points for one sprint. And it might be really accurate. So I don't think your data supports, well, at least your argument in this case.
Yeah,
if I would suggest that people look at the different cognitive biases that have been reasonably well studied now, things like the planning fallacy, and take into account how people think about problems and how they break up and assess work while you're doing it, because you can, rather than just saying, oh, we're just not very good at planning and planning is accurate, you can make it accurate by taking into account how human beings think.
Yeah, that's a really good point. With that specific data chart with story points, they did use the data from a single team. So they were at least theoretically aligned. But yeah, I do believe that we can become actually better at planning despite all of the things that I said. I just think it's just inherently very difficult. And this is not something that we can rely on to truly estimate stuff as larger teams. That's a belief. I might be wrong. If you have other experience, that's very good. I'm very, very happy that actually good planning exists. I would love to.
Take one and
I'm going to say something probably controversial.
Sure.
Should we stop reading books about developer productivity and start reading books from by other creatives involved in writing and artistry and publishing? Have we made a mistake by treating software development as something exceptional when these problems have been well understood by other creative industries for hundreds of years?
That's a very good question. I don't know the answer to that. Maybe it's not an accident that I quoted Rick Rubin 2 times today. But yeah, that would make a lot of sense to me.
Brilliant talk, very well presented. I totally agree with everything except of very weird slide which says, why do we estimate? Why do we estimate is like extremely clear for me. You need to, any job you do, you need to estimate costs versus business value that it brings. That's why we estimate like with story points, so the product owner can know how much work it is versus the business value that it brings. But you slide didn't say it.
Yeah, because before I was basically making a point that we're so bad at estimating things that it kind of, like, our predictions kind of don't make sense. You might as well toss a coin or something like that. I don't believe that too much actual value comes out of process of estimating in terms of actually getting a nice estimation of the time that it will take us to build stuff. At least this has not been my experience. It is very possible that there are other companies that are doing other things differently. I've only been in the industry for 10 years and at 5 different companies. So like there are many more companies represented here. So it's very possible that it's not the case for everyone.
In this case, I'm going to be bragging about myself. I'm better in estimating.
That is wonderful.
Yes. I'm better at estimating the coin flip than coin flipping, and I believe you can do better.
That's very good. I'm very happy.
All right, last question. Would lower granularity metrics help, i.e. T-shirt versus Fibonacci?
Yeah, that's a good question. Unfortunately, from my experience, I haven't found any big improvements, but there is very scarce research on this, unfortunately. Like there are literally just a couple of papers on the internet because it is very difficult to come by this data. So if you work at a company that measures this stuff and estimates everything and knows how much time things actually took, if you could do a research and publish it, that would be super awesome, I think, for everyone.
Okay, we're going to wrap up because it's 8:30. Round of applause, please. Mike. Okay, that is it for us tonight. Thank you so much, everybody, for coming out. Please don't forget to return your fobs on the way out, and we'll be back again on the first Wednesday of every month. See you next month. Bye-bye. Thank you. Oh, also going to the conductor, the pub. Don't forget.